Okay, this is your Unit 5, Lesson 3, Day 2 homework, or Day 1 homework, excuse me, and problem number 2 on page 381 of the Core Plus Mathematics Course 3 textbook. And so we're taking a look at another application of polynomial functions and rational functions. And so we're taking a look at this venue that you have studied several times in this unit that has constant attendance that is given by n of x equals 750 minus 25x, snack bar income that's given by s of x equals 7,500 minus 250x. Snack bar operating expenses are given by b of x equals 2,250 minus 75x. In part A, we're asked to write two equivalent rules for the function p sub b of x that gives snack bar profit as function of ticket price. Give one rule that shows the separate expressions for calculating snack bar income and operating costs, and another that is equivalent yet easier to use in calculations. So what we'll do is we'll talk about how profit is equal to income minus expenses or costs. And so we're dealing with the snack bar. Snack bar income is 7,500 minus 250x. There's your income. And then our expenses are going to be taken away from that or subtracted from that. And we'll subtract off the expenses of 2,250 minus 75x. So this is the one expression, and then this one that's simpler is the one we're going to combine like terms. So 7,500 minus 2,250. And so we take a look at that. First of all, the 500 minus the 250 is going to yield 250, and then the 7 minus the 2 is going to yield the 5,000. So we're looking at 5,250. We have a negative 250x, but then we are subtracting another negative 75. So that will be like it's added back onto this. So what we'll have then is plus 175x. Minus 175x. This became the plus. Negative times a negative is positive. So negative 250 plus the 75 becomes the negative 175x. So this is another way to write the same p sub b of x. Profit from snack bars. That's part A. Part B, for the rational functions described in parts 1 through 4, explain what they tell about the business situation, and then describe the theoretical and practical domains of the functions, the values of x which a function output can be calculated, and the values of x for which the calculation of outputs makes sense in the problem situation, and then sketch a graph for each of them indicating in vertical asymptotes and enough of the graph so the overall shape is clear. So the first part is dealing with s of x over n of x. So just lining them up, s of x is 7,500 minus 250x. N of x is the 750 minus 25x. And what you'll notice right away is that the top and the bottom really only differ by a factor of 10. So this one on top is really only 10 times bigger than what we see on the bottom. So this expression can actually be simplified down to an expression that kind of looks like, well, 10, because the top is 10 times bigger. With one key feature here, if we just graph 10, we would have this nice horizontal flat line, but it would not have the hole in it that would exist up here. 750 minus 25x would go to 0 when x is 30. The top value, 7,500 minus 250x, would also go to 0 at 30. So there's a hole that happens at 30. So this is what's happening. We would say that x equals 30 is going to be a hole in the graph, and if we were to make a sketch of this, we would see a graph that looked like it has an expression at 10. We're going to go by 2, 4, 6, 8, 10. So that's 10. We're going to make this graph, and we'll have this graph go out to 30 right there. Why not? Put a little hole there. There's a hole at 30. And that's s of x minus over n of x. In terms of what that means, we're looking at the snack bar income per concert attendance. So this is the income per attendant. This is the amount of income dollars we're making per person who comes. So this is income on snack bar per person. Okay, and it looks like we're making $10 per person. That kind of makes sense, and that's staying constant here. All right, second one, 2. B of x over n of x. Oh, I forgot about the practical domain, though. The practical domain, then I would say here, we would go from 0 out to 30. So I'll put that over here as the domain is 0. We can include 0, but we're not going to include 30 because 30 has the hole. So 0 out to 30 in interval notation for the domain. Part 2, we're dealing with b of x over n of x, and b of x is given as the snack bar operating costs. That's the 2,250 minus the 75x. And that's divided by n of x, which is the concert attendance. Concert attendance is 750 minus 25x. So here we're looking at snack bar expenses. This is the cost per person attending. So we'll put that on here, cost per person attending. And we're taking a look at the same domain, really. Essentially, the domain here is going to go from $0 that we're charging out to $30 that we're charging, because at $30, this bottom part goes to 0. And beyond that would be negative, which doesn't make any sense to us. Now, the equation for this one is not the same. We're not going to get this nice straight line here. It might be a line. I think we're going to see a line horizontally, but it's going to be more dependent upon this front ratio that occurs here. And so what I'm going to do is grab a graphing calculator, and let's see what happens. Okay, so I'm going to take a look at the graphing portion of this, and this is on a standard window right now. So I'm going to hit the tab, and I'm going to bring up 2,250. Oh, wait, one thing we want to do is make sure we have the fraction started. So I went to the rectangle key here, the script key, and selected the fraction. We'll type in 2,250 minus 75x. And then in the bottom, we'll have 750 minus 25x. I'll hit enter on that. And I do have a graph that shows up, right? And it is a nice horizontal line, and I'd be interested in seeing what that horizontal line is, but I have a feeling that that horizontal line is exactly at 3. Now, why do I know that? Well, if I look at the ratio of just 75 to 25, that number right there is kind of giving us a big idea of what's happening. And that's really the 75. Oh, I take that. That's really playing into the horizontal asymptote. And this part here is telling us a lot about the y-intercept. The y-intercept, where it crosses the y-axis, should be 2,250 divided by 750. So let's take a look at that number, 2,250 divided by 750, and that's 3. Well, that's convenient because 3 is the y-intercept, but we're also dealing with this 3 over here that is indicating some sort of perhaps a horizontal line or an asymptote that's being approached. So we're at 3 on this graph, and so the shape of this graph is a horizontal line at 3. We're going to be very careful again, just like the top one, to make sure that we include our practical domain as we go out to 30. 30 in the bottom number here would indicate the difference between 725 times 30 is 750. See how that shows up? So that would go to 0 right here if this was equal to 30. So when we reach 30, we actually have a hole in the graph that we actually don't see on the graph that's given to us. So again, we're at a horizontal line with a hole in it. Take a look at the next value at 3. Okay, so the next value at 3 is to look at PB of x, which is the profit of x over S of x, which S of x is our snack bar income. So now we're looking at profit per income, or the amount of money we make for each dollar that we take in. In the profit equation, we're going to use from the 5,250 minus 175x simplified version that we had in part A, and the S of x is going to be the 7,500 minus 250x. And the domain-wise on this one, if I take 250 and multiply that by 30, I'm going to get 7,500. So I'm going to keep the same domain from 0 to 30. But I'm going to go ahead and take a look at the graph of this and see what happens as well. Okay, and so I know I have this graph. I'm going to tab up and change the numbers. Okay, so if I change the numbers on here, I'm going to change the top part to be 5,250 minus 175x. On the bottom, 7,500. Okay, that didn't work. We'll bring it back up. And we'll change the bottom part. 7,500 minus 250x. And we have graph enter there. And look at that. It's a really small value right there. Now that's interesting why that's so small, but it appears to be, somewhere between 0 and 1. Well, let's take a look at what we're dealing with. Take a look at the y-intercept. That would be dealing with 5,250 divided by 7,500. So this is crossing at 7/10. 7/10. And so let's go back to the graph a minute. And that graph, sure enough, these are lines at 0.5, so this is 0.5 and then 1, and we're definitely between the two, 0.5 and 1 there, so we're dealing with 0.7. That seems to make good sense. Okay, so let's quick sketch that. We'll put the 0.7, and again, when we reach 30, we'll have a hole in the graph, but this is at 0.7 this time. Okay, one last graph to put on here, graph 4, and we're dealing with B of x over S of x. So B was talking about the snack bar operating costs. So B of x over S of x. B of x is snack bar costs, 2,250 minus 75x, divided by S of x, which was the snack bar income. So this is cost per dollar I take in. So every dollar that comes in, this is how much this is going to cost us expenses-wise. And right away,